bugungi ingliz tilida bo'ladi. The title of this topic on special subalgebras of derivation algebras of Leibniz algebras. We'll give introduction. The interest in study of derivations of algebras goes back to a paper by Jackson. In this paper, they are using the nilpotency property of derivations. Jackson specified one important class of the algebras called characteristically nilpotent. Since then, the characteristically nilpotent class of the algebras have been intensively and extensively treated by many authors. Motivated by the progress made in 1971, Ravi Shankar in this paper extended the concept of being characteristically nilpotent to other classes of algebras. The problems concerning the structure of the derivation algebra and its relations with the structure of Lie algebra have been investigated by several authors in these papers. Tixmer, Hofstad, Jacobson, Lager, and Togo. Since the study of the properties of derivations of Lie algebra play an essential role in the theory of Lie algebras, the question naturally arises whether the corresponding results can be extended to the more general framework of the Leibniz algebras. It is known that the right multiplication operator of the Lie algebra is a derivation. This kind of derivations are called in. All other derivations are called outer. It's well known that any derivation of finite dimensional semi-simple Lie algebra over a field of characteristic 0 is in by Jacobson proved. In the last years, Leibniz algebra have been under active research. Among the numerous papers devoted to this subject, we can find some cohomology and deformations properties, results on various types of decompositions, structure of soluble and nilpotent Leibniz algebras, and classifications of some classes of graded nilpotent Leibniz algebras. In this talk, we consider some properties of derivations of Leibniz algebras. It is the purpose of this work to extend to the case Leibniz algebras as a result of derivations of the algebras due to Togo in this paper to investigate the properties of Leibniz algebra L such that central derivation is subset of inner derivation, and Leibniz algebra L such that inner derivations is a subset of central derivation, where RL is the set of all inner derivations of L, and C that L the set of all central derivations of L, that is the set of all derivations of L, mapping L into the center. Throughout the paper, we denote by F a field of characters 0 and by L a finite dimensional Leibniz algebra over F. And we recall some basic notions and concepts used through the work. The first definition, a Leibniz algebra over a field F is vector space L equipped with a bilinear map called bracket from this to L, specifying the Leibniz identity for all x, y, z in L. And the set center such elements of L, multiplication of x and z is equal to 0 of all x in L. And next definition, for a given Leibniz algebra L, the sequence of two-sided ideals defined recursively as follows, and are said to be the lower central and derived series of L respectively. A Leibniz algebra L is said to be nilpotent if there exists an in natural number such that Ln is equal to 0. The minimal number n with such property is said to be the index of nilpotency of the algebra L. The maximal solvable ideal of a Leibniz algebra is called the radical of the algebra. We recall an analogy of Leibniz theorem for Leibniz algebra. Let L be a finite dimensional Leibniz algebra over a field of characters 0, and let R be its solvable radical. Then there exists a simple subalgebra S of L such that L is decomposed into a symmetric sum of its solvable radical and a simple Lie algebra. It was proved in this paper by Barnes in 2012. The subalgebra S of the above theorem, similarly to the algebra theory, is called a Levi subalgebra of the Leibniz algebra L. And we will give the definition of derivation. A linear map G from L to itself of the Leibniz algebra is said to be a derivation if for all x, y in L, the following condition holds. This condition. The set of all derivation of L is denoted by der L. The der L is a Lie algebra with respect to the commutator. And for a given element x of the Leibniz algebra L, the right multiplication operator Rx from L to L, defined by this force is a derivation. Yes, in the case, this kind of derivations are said to be inner derivations. Let the set of all inner derivations of the Leibniz algebra L denoted by RL. A derivation Z of L is called central, provided that it maps L into the center of L. We do not consider L the set of all central derivations of L. Central derivations of L is a subalgebra of derivation algebra of Leibniz algebra.
It's a Lie subalgebra, yes?
Yes, yes.
Mm-hmm.
Then an endomorphism phi of L is a central derivation if and only if it maps L into the center of L and L square into the 0, i.e. This forms.
Derivation if only if it maps all algebra into its center and the derived algebra into the 0, yes. So in the case of Lie algebras, it's the same definition, right?
Yes, yes.
In the Lie algebras also is defined as such.
Yes.
Yes. Okay.
And we will give example. Let L be the Leibniz algebra of F described in terms of basis E1, E2, E3, E4, E5 by the following table. It's
five-dimensional. It's five-dimensional Leibniz algebra. Yes.
Yes, finite dimensional.
Five-dimensional.
Leibniz algebra. It's nilpotent Leibniz algebra. The matrix form of this derivation algebra is this following forms, and from this the matrix.
Hozir anaqa Zarina. Unda yozish noto'g'ri, chunki der L это множество всех дифференцирований. Bu yerda mana bu anaqani matritsani figurniy skobga olib qo'yish kerak edi. Bo'lmasa bu yerda bitta element bo'lib qolyapti. Tushunarlimi? O'ng qo'lda bitta matritsa-da, u bitta differentsирование. Chap qo'lda множество всех differentsирований. Davom eting.
From this, the matrix of and inner derivations is obtained. And the matrix of the central derivations is obtained these forms. Thus, derivation algebra is 7-dimensional, and inner derivation is 3-dimensional, and central derivation is 2-dimensional. And inner derivation intersection of inner derivation and central derivation is 1-dimensional in this form.
Hozirgi mana bu Shavkat aka aytganlaridek bularni ham qavsga olish kerak. Birinchidan, ikkinchidan oxirgi tenglik bu bir elementli to'plam bo'libdimi bu?
Da, bir element.
yoki shu orqali
hosil bo'lgan qism algebra.
Span deb yozish kerak edi, bo'lmasam span.
Yoki lambda operator kerak, просто.
Да.
Лямбда пробегает поле комплексных чисел.
Они F. Bir kompleksni qaralgan. Kompleksni qaralgan.
Algebra zaмкнутый bo'lsa, unda просто поле.
Span deb yozsa ma'qulroq, chunki odatda shunaqa qilishadi.
Одномерный bo'lish kerak. Bu bitta bo'lib qoladi, bitta element bo'lib qoladi bu yozuvingizda.
Tushundim.
Davom eting.
And we will give main results. We study the derivation.
Savol bor edi. Hozir bu misoldan nima xulosa qilmoqchisiz hozir? Shuni sal tushuntirib keting, Zarina.
Men ichki differensiyalashlar va markaziy differensiyalash orasidagi bog'lanishni o'rgandik. O'shani berish uchun oldin misol keltirib oldim. Endi natijalarga o'tish uchun.
Bu yerda demak markaziy differensiyallash ichki differensiyallash ichida yotmaydi, to'g'rimi?
Yo'q, yotmadi. Lekin umumiy qismga ega.
Misolda.
And we will give main results. We study the derivations of Leibniz algebra, which at the same time inner and central. The first proposition, let L be a Leibniz algebra over F, and let ZL be the center of L, and R and R1 be the radical of L and derivative L, respectively. Then, firstly, intersection of inner derivation and central derivation is equal to this set, these forms, where Z1 is the set of all elements of L such that multiplication of L and L is belong to center.
juda ham tushunarli emas.
RL nima degani? RL. RZ.
Inner derivations, set of inner derivations.
Inner derivations of L intersected by central derivations coincide with inner derivations of Z1.
Yes, yes.
Where Z1 is set of elements such that L. Okay.
And secondly, intersection in derivations by central derivations is going to inner derivations on Z2, where Z2 is the set of elements R of radical of L such that multiplication of radical of derived algebra L and R is equal to 0. And we will give a remark, the first remark. Let L be a non-abelian nilpotent Lie algebra. Then intersection in derivations and central derivations is not equal to 0. But there exists non-Lie nilpotent Leibniz algebra such that intersection of inner derivations and central derivations is equal to 0.
Hozir oldingi teoremani ma'nosi nima? Mumkinmi yana? Mana bu teorem ikki qismdan iborat. Bittasi shu kesishma bunga teng bo'ldi deyilyapti. Ikkinchisi o'sha kesishma buni ichida yotdi deyilyapti. Demak, bu degan so'z RZ1 RZ2 ni ichida yotibdi, shunaqami? Hozir RZ1 algebra, RZ2 ham algebrami? Bular pad algebralarmi? Derivation algebrami?
Subalgebra.
Demak, birinchisi pad algebra, ikkinchi pad algebra ichida yotibdi deganim bu?
Shunaqa.
Там они равны, здесь включены. Здорово. Значит, RZ1 лежит в RZ2.
Да.
Как пад алгебра, да?
Да.
Понятно.
Браво.
Так.
We'll give example. We consider an dimensional uniform Leibniz algebra. This forms, and we are E1 from E1 to En is the basis of the algebra. No field for Leibniz algebra. The center of algebra is equal to En. From this paper, we know that any derivation of the algebra null field form has the following matrix form. And by using the matrix, it is immediate that inner derivation is consists of only E1 and central derivation is consists of D derivation such that D is mapping E1 to En. But in the derivation, intersection of in the derivations and central derivations is equal to 0.
Hozir mana bu by using the matrix degani yaxshi aytilmagan. Nima degani by using matrix? By using the matrix form of the derivation.
Matrix form, yes, matrix form.
It is immediate to state that RL equals betem spam bo'lsa kerak endi.
Shunaqasini xato yozman.
Bu bir. Ikkinchidan mana bu example'ni keltirishingizni motivatsiyasi nimadan iborat? Nima demoqchisiz bu yerda endi o'sha mana bu.
Ha, oldin uzoq remarkni aytdim. Ya'ni li algebrasida, nilpatent li algebrasida har doim bu ikki ichki differensiyallash bilan markaziy differensiyallash doim noldan farqli bo'ladi. Leibniz algebrasida shunaqa o'sha nol form algebra borki, bu ikkalasini kesishmasi nol bo'lib qoladi. Ya'ni li algebrasidan shu farqni topib ketishdi.
Leibniz algebrada li algebradan farqli natijalar bor demoqchisiz.
Ha, shunaqa.
Ha, aslida bir remarki undan oldin aytib turib, keyin misol keltirgan menimcha mantiq nuqtai nazaridan ma'qulroq bo'ladi shekilli.
Keyingi misolda mana shu ko'rinadi betish kerak edi, keyin misol ko'rsatish kerak. Shunda misol nimaga keltirayotganingizda savol bo'lmaydi.
Hop. And we will study the Leibniz algebra with condition central derivations is subset of inner derivation. The first lemma, let L be a finite dimensional Leibniz algebra over a field of characters 0 whose radical is abelian. If central derivation is subset of inner derivation, then as the center of L is equal to 0, all L is equal to a derivative of algebra.
Hozir bu holni o'rganishi sababi osonmi? Shuning uchun faqat natija olinganmi yo bundan boshqa bo'lgan hollar, ya'ni ichida yotmagan paytda ham qanaqadir o'rganilganmi? Mana bu study the Leibniz algebras with condition deyapsiz-da. Bu degan so'z bu holi oson bo'lgani uchun qilyapsizmi yoki qanaqadir ma'nosi bormi buni ichida yotishda?
Preoptizionniy uslubiy описание olinmoqchi-da, deyman.
Har xil holatlarni qaradikda, buni ichida yotgan va teskarisi ichki differensiyallash central derivation ichida yotgan holni, keyin ikkalasi ustma tushgan holatlar. Li algebrasida shular qaralgan, shularni olib o'rganib, qanchasi Leibniz o'tadi yoki qaysi qismi Leibniz o'tmaydi, shularni o'rgandik.
Radikal abeliy bo'lishi nima uchun talab qilinmoqda? Bu qattiq жесткий условия-ku bu.
Bu
whose radical is abelian.
Bundan keyin teorema beraman, o'sha teoremadan oldin shu lemmani bergandim. Bu yerda o'sha teoremada mana shu lemmani teskarisi aytiladi. Tushunarli.
Uzr, ana bu togo boshqalarning ishlarida maydon ixtiyoriy xarakteristikasi 0 bo'lganmi, faqat yo kompleks deyilgan qaralganmi? Shuni esimda yo'q meni.
Xarakteristikasi 0 bo'lgan maydon.
Ixtiyoriy xarakteristikasi 0 bo'lgan maydonida?
Ha. Chunki boshida hammasi shunaqa keltirilgan. Togon juda ko'p maqolalar bor ekan, differensiyallash algebralar bo'yicha shularni o'rgandik.
Yaxshi.
And in this example, we'll give let L be 5-dimensional Leibniz algebra with the basis, this basis, such that products of the basis vectors in L are represented as follows. And here S is simple subalgebra and R is abelian radical. And in this algebra, the center is equal to 0 and derivative L is equal to L, and in derivation is and central derivation is equal to 0.
Hamma joyda span deb yozish kerak qatta bitta. Chunki 3 ta elementli o'qibdi.
Shuni xato yozibman.
Da.
And the next example, let L be the direct sum of the Leibniz algebra in example 3 is a non-zero abelian Leibniz algebra. Then the center is not 0 and central derivations is not 0. It is not difficult to see that central derivation is not contained in the derivation. In particular, we consider the Leibniz algebra L1 plus a direct sum E6, where L1 is 5-dimensional algebra in example 3 is at and E6 is abelian ideal. Then the matrix form of derivation algebra is this form. And from this matrix, we see that in the derivations is consist of this, and L has non-trivial central derivation D is not equal to 0, but it is not contained in the derivation. And then have the following result. Let L be a Leibniz.
Ana shu yerda men bu Y6da abel ideal bo'ladi deyapsiz-ku, mana shu algebrani. Mana differensialni hisoblaganda mana bu Y6 butun algebraga tushishi kerak edi. Mana bu o'sha Y6dagi mana oxirgi satrni nolligi menimcha xato emasmi? Chunki Y6ga ko'paytirgan hamma elementlar 0 bo'lsa, bu yerdagi koeffitsiyentlarni aniqlab bo'lmaydi-ku. Oxirdagi fatordagi koeffitsiyentlar.
Menimcha yo'q, hisoblab chiqqanda 0 chiqqandi shunaqa. Yana bir hisoblab ko'raman, lekin shunaqa chiqqanda.
Shunaqa chiqqan-a?
Ha, shunaqa chiqqan, hisoblab ko'rgandim.
Abelian ideal degani o'sha E6ni E6 ko'paytirganda 0 bo'ladi deganda, to'g'rimi? Boshqa hech narsa emas.
Ha.
To'g'rimi?
Ha. In this theorem, let L be a Leibniz algebra over a field of characteristic 0 if the center of L is not 0 and if central derivation is subset of inner derivation and central derivation is not equal to 0, then the radical of L is not abelian. Yani bu yerda lemmadan foydalanib, keyin bu teoremani isbot qildik. Lemma yordamida.
Emasmi? Li algebrali holida bu qanaqa teorema o'rinlamasmi? Yoki bu qaralmaganmi? Li holida hech qanaqa bu to'g'risida gapirilmaganmi?
Bu qaralgan algebrali holatida.
Xuddi shu teorema bormidi ham, yo boshqacharoqmi formasi? Teorema ikkini.
Chunki li bilan bog'lab gapirilganda ma'qul bo'ladi, chunki li uchun olgan natijalarni siz extend qilyapsiz.
Ha, shunaqa.
Li uchun ham xuddi shu formada yozilganmi, terimada so'ralyapti.
Shunaqa edi, li uchun ham. Ko'rinishi shunaqa edi. Faqat o'sha biz isbotida biz antikommutativlik yo'qligi uchun ba'zi qo'shimcha narsalarni qaradik.
Terimani formulovkasi xuddi shunaqa. Shunaqami?
Shunaqa
aynan shunaqa.
Hozir aniq esimda yo'q, buni yozib chiqishdan oldin.
Endi qarash kerak-da. Agar formulovkasi farqli bo'lsa, uni tushuntirish kerak. Nima uchun bir xil bo'lsa, u boshqa gap. Unda bu непосредственно o'shani обобщенияsi bo'ladi. И те же условия bo'lgan bo'lsa, такой результат.
Boshqa bo'lsa qayta qiziq bo'ladi. Chunki bu Leibniz algebra, Li algebradan farqini bildiradi-da.
Tushundim.
Bu kimni teoremasi edi Li algebra holida?
Tog'oni maqolasida keltirilgan.
To'g'on maqolasiga yaxshilab qarang-da bo'lmasa.
Xo'p.
Xo'p, davom eting.
And we consider the Leibniz algebra whose all linear derivations are central. We prove the following. The search theorem, let L be a Leibniz algebra over a field of characters 0, then inner derivations is subset of central derivations if and only if L cube is equal to 0.
Xuddi shu savol. Li algebrada ham xuddi shunaqami?
Li algebrada 3-teorema xuddi shunaqa. Faqat biz isbot qilishda antikommutativlik yo'q bo'lgani uchun o'zimiz qo'shimcha narsalardan foydalandik. Li algebrada teoremani ko'rinishi shunaqa.
O'zi shunaqa algebralar bor ekanmi? Zarina, mana shu teorema shu qanoatlantirilgan algebralar?
Bor, hozir. Mana shu har biri uchun misollar ko'rib chiqdik. Hozir teoremani aytib bo'lgandan keyin teorema uchun misollar keltiraman. And next theorem, let L be a Leibniz algebra over a field of characters 0. Then derivation algebra is equal to central derivation algebra if and only if L is abelian. And this theorem is true for Lie algebra. And the next theorem, let L be a Leibniz algebra over a field of characters 0. Assume that the center is equal. Center is not 0. If inner derivations is equal to central derivation, then L square is equal to center, and dimensional of center is equal to 1.
Yana bitta savol, uzr. Mana bu xarakteristik 0 deganni sushestini foydalanilganmi o'tbetda u isbotlarida? Shunga e'tibor qildingizmi? Xarakteristik 0 bo'lmasa isbotlash mumkin bunaqa narsalarni?
Hammasida nol xarakteristikali maydon ustida qaradik. Chunki o'sha boshida kiritgan tariflarning hammasi nol xarakteristika maydon ustida qaralgan. Shulardan foydalanib isbotlarida shulardan foydalandik. Shunga hammasi teoremada nol xarakteristikali maydon ustida deb berdik.
Nol bo'lmasa nima bo'lar ekan? U to'g'risida o'ylab ko'rmadingiz hali.
Yo'q, buni qaraganimiz yo'q.
Xo'p, demak, bu teoremalarning formulovkasi birontasi farq qiladimi? Tog'oni teoremasi formulovkasini?
Hozir endi shuni aytmoqchi edim. 3-chi va 4-chisi zarur va yetarli shart. Li algebrasi uchun ham shunaqa bajarilarkan, Leibniz algebrasi uchun ham shunaqa bajarildi, zarur va yetarli shart. 5-chi teoremada bir qismi bajarildi. Hozir shuni aytib o'tmoqchi edim.
Evet.
And we'll give example for theorem sort. We consider the Leibniz algebra specifying the condition of theorem sort. Let L be the nilpotent Leibniz algebra of F described in terms of the basis from E1 to E5 by the following table. For this algebra, center is consists of spanned by E3, E4, and E5, and L cube is 0, and derivation form is this following form. And in this example, inner derivation is a subset of central derivation. Ya'ni uchinchi teorema shartini qanoatlantiradigan, hozir Jobir aka savol bergandilar. Shunaqa algebralar bormi deb ko'rdik. Mana shu uchinchi teorema shartlarini qanoatlantiradigan algebraga bu misol keltirildi. And we'll give a remark. We'll here note that the converse of theorem 5 is true for the algebras. But in the next example, we'll show that there exists a Leibniz algebra which does not specify the converse of theorem 5. Let L be a Leibniz algebra over the field of F, described in terms of a basis. This by the following multiplication table, and this algebra L square, and the center is consists of E5. Moreover, see that the matrix form of derivations of L is form. And in this example, inner derivations is 3-dimensional, and central derivation is 4-dimensional. And it's easily shown that inner derivation is not equal to central derivation. But in the algebra, the converse of theorem 5 is true.
What does it mean, the converse of this theorem? Nima degan, teskari degan nima tushunadi bu teoremni?
If the algebra square L is equal to center and dimension of center is equal to 1, then inner derivation is equal to central derivation.
Okay.
But in Leibniz algebra is not true.
So in Lee case, if central and inner coincide, if and only if L square is ZL and dimension of ZL is equal to 1. If and only if.
Shunaqa.
Hop.
Bizlarni o'rganib, shu central derivationlarni o'rganib, bu central derivationlarning tarifi Usmonoddin akani ham maqolalarda keltirilgan ekan. Central derivationni Leibniz algebralar uchun qidirganimda shu maqolalar chiqdi, o'shani tariflar kiritilgan ekan.
Kim maqolasi?
Rahim Husamoddin akani maqolasi Rahim Husamoddin. Tariflar central derivation Leibniz algebralar uchun central derivation tariflari kiritilgan ekan shu maqolalarda.
Sizda qilinganmidi bu? Samiddin?
Labay. Shokir aka.
Sizni eslayaptilar-da, Zarina.
Ha, eshityapman. Hozir kutyapman qanaqa ekan, qaysi maqola ekan. Chunki derivationlar
2017-yilda chiqargan maqolangiz ekan.
u Leibniz uchunmidi o'sha?
Ha, Leibniz uchun.
Okay.
Darslarni o'shanda oldim. Derivation chunki boshqa derivation tariflari kiritilgan, lekin algebra uchun maqola ko'rmadim. Algebra uchun bor anchagina maqolalar.
Tushunarli. Xo'p, davom eting. Bo'ldimi?
Ha.
Marhamat, savollar. Seminar a'zolari. Savollar. Paxo'da biz Samiddindan berdik. Kimda yana savollar bor?
Mani yana bitta savolim bor edi. Professor Hakimjonov xarakteristik nilpatentni li algebralarni o'rgangan. U esimda bo'lsa, u geometriya nuqtai nazaridan o'rgangan. Esimda bo'lsa, isbotlaganki, xarakteristik nilpatentni algebralar juda ko'p. Ular qaysidir algebralar, li algebralar sinfini bitta komponentasini tashkil qiladi degan bir ajoyib natija olgan. Xo'p, o'sha narsani Leibniz uchun qilinsa, juda ajoyib narsa bo'lardi. Tekshirib ko'rilsa. Leibniz uchun ham shunaqami yoki yo'qmi? Bu ben doktorlik dissertatsiyasini bir qismi bo'lgan o'sha Hakimjonov. Shu mani esimda bor.
Maqolalarni ko'rgandimmi?
Lekin sizga bu yerda Hakimjonov ishlariga siz hech qanaqa referens bermadingiz-da, o'shaning uchun men o'ylabman, ko'rdingizmi yo'qmi deb degan ma'noda savol beryapman.
Ko'rgandim.
Keyin Zarina, hani bir 4-sinfga borsangiz agar to'rtinchi. Mana shu slaydga. Demak, men bu 10-ga murojaat qilyapsiz-ku, 10 maqola. Bu aslida birinchi Whitehead lemmasi deb ataladi-da. Birinchi Whitehead lemma. Endi birinchi Whitehead lemma, men bitta agar nomida ham qarasangiz, Simple Jordan algebrasda. O'sha yoki Jacobs'ni kitobiga berish kerakmikin, silkani. Tushundingizmi? Bu bo'lmayapti.
Da, bitta Jordan yozilgan, o'rta li algebra, to'g'ri.
Da. Keyin hali men bu rezultat teoremalaringiz olyapsiz-ku, bular faqat shu kichkina o'lchovlarda teoremalarni olyapsizmi? Haligi
misollar-ku kichkina o'lchovli. Teoremada o'lchoviga ограничение yo'qmi?
Yo'q, unda men bu описанияларда bor-ku. Bo'ldi. Ularni ko'rganimda. Bo'ldi, boshqa savol yo'q menda.
Misollarni qarayotganimizda kichik o'lchovlilar uchun tekshirib ko'rgandim. Misollarni kichik o'lchovlilar uchun bergandim.
Marhamat, yana savollar.
Xo'p, yana oxirgi savolim, demak, teoremalarning isboti bor-ku, li algebradan farq qiladimi yoki yo'qmi?
Farq qiladi.
Farq qiladimi? Yaxshi.
Farq qiladigan qismlar bor.
Yaxshi.
Faqat mana shu обозначенияларni to'g'ri qilish kerak. Span yozish kerak yoki boshqa mana shu formulovkalarda strof yozish kerak.
Bular qayerda publikatsiya qilingan o'zi?
Qilinmagan bo'lsa kerak hali.
Hali Lenikini Tobon maqolasida publikatsiya qilingan u, buni hali publikatsiya qilganimiz yo'q. Abror aka bilan birgalikda shu natijalarni oldik.
O'shani endi pulga qiladigan bo'lsanglar, mana shu anaqalar hammasi tuzalishi kerak, замечаниялар.
Tushundim.
Так, Abror, sizda kommentariy yo'qmi?
Agar mumkin bo'lsa, ozgina gapirardim. Haqiqatan boya savol aka to'g'ri savol berdilar. Nima uchun sentralniy derivation bilan inner derivationga mana bunaqa shartlar qo'yilyapti deb. O'zimda olganda sentralniy derivation qaysidir ma'noda inner derivationga yaqinroqdir, lekin farq qiladigan jihatlari bor. Boya yuqoridagi misollarda ham Zarina ko'rsatdi. Nima uchun shu holda qaraydi degan haqiqatan to'g'ri. Li algebra holatda ham shu ular yaqin bo'lgandan keyin ustma tushgan holatda qanaqa bo'ladi, bir ikkinchisining qismi bo'lgan holatda qanaqa bo'ladi degan savolga qaralgan. O'shani analogi sifatida Leibniz algebrasi uchun qaralgan. Bu ham natijalardan ko'rinib turibdi. Shu bilan birga farqli jihatlariga misollar keltirib, Zarina hammasini keltirgan. Yaxshi ish bo'lgan. Men endi asosan o'zlari shug'ullanganlar, men sal qarab o'sha misollarga qarashib aniq turganman. Asosan lekin samosiyatning o'zlari shug'ullanganlar, natijalari yomon emas. Bugungi darsda ancha foydali bo'ldi. O'sha kamchiliklarni to'g'rilab aniq qilib olamiz.
Tushunarli. Yaxshi. Bo'pti, Zarina, ishlaringizga omad.
Yana bitta savol bordi, Shokit aka, uzr. Ana bu Li bilan Leibnizni farqlari bir xil yoki bir xil emas, natija unda bor, bunda bor deganlarni sal bo'rtirib ko'rsatish kerak edi, chunki bu yerda u juda ham bo'rtirilmagan.
To'g'ri.
Li ancha foyda beradi shu narsa.
Li uchun mana bunaqa, Leibniz uchun mana bunaqa deb turib bo'rtirib aytsa, u holda bu ancha impact beradi-da.
To'g'ri, o'sha savol beryapti, nuqul Lida qanaqa deb. Shuning uchun doim сравнение bo'lishi kerak. Yaxshi, rahmat. Boshqa savollar, takliflar yo'qmi? Xo'p, rahmat bo'lmasa, Zarina, rahmat, ishlaringizga omad. Xo'p, keyingi seminarda Jobir, zaявkalar bormi?
Keyingi seminarda o'tgan o'quvchilari Vohonib Zafar birinchi kurs tayanch taqdiratlari taklif qilar ekan, keyingi dushanbaga.
Yaxshi. Bo'pti, bo'lmasa hammalarning kelayotgan hayitlar bilan tabriklayman. Bayramlarni, hayitlarni yaxshi o'tkazinglar. Hammamiz sog' salomat bo'laylik. Rahmat.
Rahmat.
Rahmat
Rahmat sizga.
Sog' salomat bo'linglar.